Okay, this is your pre-lab video for your cell transport lab. What you're going to do is you're going to have 3 cubes. I'm not going to draw cubes because I'm just not. Well, I didn't even draw a square right there. So you're going to have 3 cubes of different sizes. Okay, you're going to have, that one even just goes right off the page, doesn't it? So we have a small one, we have a medium one, and we have a big one. So, and these cubes are going to be made of a substance known as agar. Now, agar is, it comes from seaweed, and it is used as a solid medium to grow bacteria on. And we're going to use it for a diffusion medium. So you're going to have agar, and in that agar, you're going to have a substance known as phenolphthalein. So phenolphthalein. Now, many of you are familiar with phenolphthalein. Those that did titration, that was the little chemical, the alcohol-based chemical or alcohol-diluted chemical that when you add it to a substance that is basic, it'll turn bright pink. So what you're going to do is you're going to make this agar with phenolphthalein, so it pretty much becomes a pH indicator cube. And then what you'll do is you'll take your cubes and you're going to put them in some basic solutions, which of course would cause your cubes to turn pink. Now the base that you're going to have is going to be sodium hydroxide. It's going to be 0.1 molar, and the as the sodium hydroxide diffuses in, it'll change the agar to pink. Okay. Now you'll let that diffuse, all 3 of these, all at the same time, all in the same conditions, for approximately 10 minutes. And then you're going to do your very best Fruit Ninja impression, and you're going to cut these cubes in half, and you're going to measure how far the pink has diffused into, or the sodium hydroxide has diffused into the agar cube, and you'll be able to tell because the phenolphthalein that's in the agar will turn the sodium hydroxide, or turn the agar pink. Okay? So, now here's the thing. From this, what I want is a rate of diffusion. I'm not going to, I'm going to spell US. Okay? I want you guys to determine the rate of diffusion for this. Okay? Now, obviously the independent variable that we're looking at right here is going to be different cell size. Now, there's other things that I want you guys to be testing the rate of diffusion or seeing what affects the rate of diffusion, and I'm leaving that completely up to you. But obviously, when you guys are doing your preparation for your second portion of the lab, you should all have cubes of the same size. So my recommendation is when you guys are doing this lab, I would probably have 1 of these guys, 1 of these guys, and then have 4 of these guys. And so when you have 4, that means 1 of them is going to be used for this particular experiment, and then the other 3, right, they're all going to be in the same size. I'm going to make them nice and right, yeah. Anyways, all 3 of those cubes are now the same size, and you can test other variables and see how they affect the rate of diffusion. Now, if you pay attention in class, you should have some idea as to what could possibly cause a change in the rate of diffusion. So that part is on you, okay? But your lab report will reflect both of them. You're going to look at what things affect the rate of diffusion. Obviously, you know one of them is going to be cell size. You're going to prove it with your experiment. And then the other thing that causes rate of diffusion is whatever you want, and then it'll cause the rate of diffusion change by using science. Okay, and you'll be using that in your description and in your discussion. Okay, that's pretty much it. Pretty short video. If you guys have any questions, ask. Okay, closed-toed shoes. We're goggling up. Okay, sodium hydroxide make you blind really quick.